This is Brandon Allen for Math 1510, assignment 3. The question I've chosen to do is 2b, which asks to give an intuitive justification for why this recursive expression gives us the maximum amount of comparisons required for the merge sort algorithm C of k, where the number of elements in the original list, n, equals 2 to the k. So the first part to the expression to explain is this 2 times k of the minus 1, 2 times c of the k minus 1, and that comes about because this portion of the explanation, this portion here is just a merge sort of k minus 1. And the reason that is because n over here equals n minus 2, it's divided in half, and it divides in half evenly because n is even, because it's 2 to the power of k. It divides evenly all the way down until it gets into these single elements. So n over 2 equals 2 to the k minus 1 in this situation. So the amount of comparisons here is c of the k minus 1 by definition. It's also c of the k minus 1 here by definition, because we're just doing the same merge sort algorithm but for k minus 1, n is half the size. Now this extra part on the end comes about when we merge these two lists into a larger list of length n in order, sorted. And the reason that comes about is these lists are compared in this way. So comparisons sort of ladder down all the way to n. So there's n amount of elements being compared in total, and all these arrows refer to all of those comparisons. So 0 is compared with something, that is compared with something. In fact, there's an arrow coming from every single one of these elements except for n. So there's n amount of comparisons, but n isn't compared with anything, so it's n minus 1. So there's n minus 1 extra comparisons that occur, but n equals 2 to the k. So it's 2 to the k minus 1 extra comparisons. So you have two lots of c of the k minus 1 comparisons occurring in c of k, plus these last comparisons that occur when you make up the final list again. Right.